Hello everyone, welcome again in Eng-Man YouTube channel. So we will have another Q&A video, and today's topic is about capillary pressure, right? So we have a very interesting question in front of us, and I use a case from Tarek Ahmed book, Reservoir Engineering Handbook. This is a very important and interesting book for reservoir engineers, right? And this is the case of capillary pressure that we need to solve. Right, so the case is like this. The reservoir capillary pressure and saturation data of the oil reservoir is shown graphically down there. Yeah, right, but I'm going to show it later. And then from the geophysical log interpretations and the core analysis, we have the water-oil contact at 5023 in feet. All right, 5023 in feet. That's our WOC, water oil contact. And we also have other data, such as oil density, 43.5 pound per cubic foot, and then water density, 64.1, and also interfacial tension, okay, 50. And then now we need to estimate or calculate the connate water saturation, SWC, and then also the depth to FWL or free water level, thickness of the transition zone, and depth to reach 50% of water saturation. Okay, so we have, only this data, water oil contact depth, oil density, water density, interfacial tension, but we need to address these issues: connate water saturation, and then free water level, and then thickness of the transition zone, and depth to reach 50% of water saturation. And by the way, we also have this plot. Okay, I'm going to use, okay, just some polishing. All right, so now we have the capillary pressure curve. So PC in PSI against water saturation, of course. And then we know that the water oil contact depth is at 50 to 3. And then, of course, somewhere down there, we have the free water level. All right, and just using the available data as well as this capillary pressure curve, now we need to deal with these issues. And of course, we also have very important equations, all right, like how to calculate the free water level if you know the water oil contact. We are going to use this. So FWL equals to WOC, water oil contact, plus 144 multiplied by PD divided by delta rho, okay? And then PD is the displacement pressure. And then this is the density difference, all right? And of course, free water level and water oil contact. And then we need also, or we are going also to use this H. H is height above free water level, and then PC, and then density difference. Okay. By the way, this displacement pressure, it's very important. So displacement pressure is the finite capillary pressure at 100% water saturation that is necessary to force the non-wetting phase into a capillary filled with the wetting phase. All right, and then this PD occurs here at this point. So the capillary pressure at this point where the curve changes the trajectory, this capillary pressure at this point is called displacement pressure. All right, this is the minimum capillary pressure at 100% water saturation that is required to force the non-wetting phase, in this case oil, into a capillary filled with the wetting phase or the water. right? Or in other words, it's the minimum capillary pressure that is required, that is necessary to kick the oil out of the pores so that the water can occupy the entire room and then reach 100% water saturation. Okay, so that's the thing. And of course, now we need to solve everything. First, we need to deal with the connate water saturation. It's very simple. If you have the capillary pressure curve, you can easily find this water saturation. So I'm going to use shapes and then arrow. Of course, connate water saturation, we can take the information from this. All right, because at this position, at this, at this location, we have pure oil. All right, that is mobile. And then water exists at its lowest saturation in the pores. And we call that connate water. And the saturation of it is the connate water saturation. All right, you cannot go below this saturation. Okay, this is the minimum capillary pressure possible for this oil water system. Okay, so just use arrow and then maybe I can make it bold, make it red, make it dashed. Okay, so you get that. So the water saturation is W based on the capillary pressure curve that we have is easily 20%. Okay. All right, so this is the answer. So we have the first thing, the water saturation or the connate water saturation, SWC, is 20%. And then the second thing is, of course, the free water level, FWL, right? And then 15. Okay, so we are going to use this formula. And then, of course, we need the water oil contact. Okay, I'm going to use this. WOC is at 5,023 in feet. Okay, I'm going to use 15 for all of them. And then we also have this displacement pressure. We need to look at this curve. So roughly, the displacement pressure based on the available capillary pressure curve that we have occurs here. I'm going to make point. Okay, so this is the minimum capillary pressure required to get rid all of the oil from, from the room, from the pores, so that water can occupy the entire space and then reach 100% water saturation. Okay, so roughly speaking, okay, yeah, maybe like this. Just roughly, okay, for simplicity, we will use displacement pressure of PSI, 1.5 PSI, but the accurate values should be somewhere here. Okay, or maybe 1.75 instead. And then, of course, we have to use density. And then symbols for the oil as well as for the water. Okay, and then we know that the oil is 43.5 pound per cubic foot, and then here, format cell, superscript, and this should be 64.1. All right, so that the free water level is water oil contact plus 144 multiplied by the displacement pressure of 1.75 divided by this density difference. Of course, the heavier one subtracted by, the lighter one. Then close the parenthesis. There you go. So our free water level depth is at 5,035 feet. Okay, so yeah. So here, this free water level is at 5,035 feet. Very good. All right, so that's the second point. And then thirdly, thickness of the transition zone. All right, maybe we can call this transition like this. H for thickness, format cell, subscript. Okay, I think it's quite cool. Okay, so yeah, we need to think a little bit. So the transition zone is, of course, here, starting from here. All right, and then down to the water oil contact. Okay, here, the position where we have, water saturation greater than the connate water saturation. Okay, so that's the thing. Starting from this depth, somewhere here, down to the water oil contact. Okay, and of course, if you look at this vertical axis from this, maybe you can use this. From this location down to this location, the value that we have is the capillary pressure. So when we are asked about thickness, we need to convert this capillary pressure to be thickness, to be something like depth. And we can do that, converting from pressure to depth or to thickness. Okay, and the form of the equation will be somewhere like this, something like this. Okay, and then it's very easy. So the thickness of the transition zone should be 144. This is the conversion factor, and then multiplied by the difference in capillary pressure. All right, easily the thickness will be based on the difference of capillary pressure. The greater one should be here, 6, and the lower one, the lowest one should be this, which is 1.75. All right, the displacement pressure. And then again, to convert from pressure to depth or to thickness, you need to divide them with density, or in this case, of course, the density difference. 64.1 minus 43.5. There you go. So the thickness of the transition zone is 29.71 in feet. Something like this. Very easy, right? So the transition zone thickness is 29.7 feet. All right, very easy and very interesting. And lastly is the capillary pressure at water saturation of 50%. So we have the picture already there. Okay, and we are asked the depth to reach 50% water saturation. Okay, the solution will be something like this, of course. All right, and then of course, the depth, the location. What's the symbol? Maybe H or this, and then this SW 50%. Okay? Yeah, you understand what I mean. All right, so it's very easy. The solution will be like this. So it's 144 multiplied by here. So the PC here, by the way, just check it. Depth to reach 50% water saturation. So the solution is here. We already have this actually. So H, the symbol is big H. It's 144 multiplied by the capillary pressure and then divided by the density difference. It's the height above the free water level. So it's very easy. Just use H instead for simplicity. And of course, this is 144 multiplied by this capillary pressure at water saturation of 50%, which is 3.75 here, all right, or maybe 3.5. And then divided by the density difference. Okay, so it's 24.5 feet, all right? But by the way, this is the H, height above free water level. It's not the absolute location. It's not the absolute, position. Okay, and then of course, the location, maybe I'm going to use this symbol. Of course, the free water level, okay, needs to be subtracted, needs to be subtracted by this H. Okay, so it's 5,010.8 feet. Okay, so this is actually the depth here. Yes, so the location of, the water saturation of 50% here, the depth is at 5,010.8. All right, so that's the solution. Okay, so now by the available data that we have, we can calculate the connate water saturation. We know the depth to free water level. All right, and then we know also the thickness of the transition zone, as well as the depth to reach 50% water saturation. All right, and just lastly, look at this capillary pressure curve. So above this location, actually we have the capillary pressure, but of course you can convert it to depth. So above this depth, only oil will flow. All right, between the top of the pay down to this location. But if you have your perforation here between this depth down to this water oil contact, so if the perforation, the completion is located somewhere here between this depth and the water oil contact, then oil will simultaneously flow with water. Okay, and by the way, I can calculate this location. I can predict this location. So it's very easy. It must be 5023, the water oil contact, minus the thickness of the transition zone, 29.7 in feet. All right, so bingo. So between 4,993 and 5,023, if you set your perforation here between these two depths, between these two locations, oil will simultaneously flow with water. But above, if you place the perforation above 4,993, only oil will flow because water will exist at its connate water saturation. Okay, so I think that's all. I hope you enjoyed this video. I hope this video about capillary pressure is useful. Thank you so much for watching. See you again in the next Q&A videos. Thank you.